So in this video, we are going to discuss one question which is from JEE Advanced 2023, and that is coming from the topic of thermodynamics. So let's see that we have one mole of an ideal gas is there, and that ideal gas is monoatomic in nature. It undergoes two reversible processes, A to B and B to C. So from A to B and then B to C, it is going like this. Now A to B, as far as the question is concerned, it is given as adiabatic in nature, that we can see from here. And B to C, the process from the graph itself, we can say that as the temperature remains constant throughout B to C, that will be an isothermal process. Now the heat absorbed in the entire process from B to C, A to B and B to C is RT2 ln 10. So what we can do, since it's adiabatic process, so we can say the Q will be equal to 0, and since it is an isothermal process, the Q will be equal to nRT ln volume final and the volume initial, that we know from the formula. It is isothermal reversible involving ideal gas, so we can apply this formula. N value is equal to 1, R value is R, temperature is T2 is given because B to C the temperature T2 is maintained, ln, and final volume is V3 and initial volume is V2 itself. So from the above discussion, we have understood that if you are going from A to B, then Q will be equal to 0. If you are going from B to C, then the Q will be equal to RT2 ln V3 by V2 itself. And since we are seeing that V3 is greater than V2, that means Q will be equal to positive quantity. Positive means it will be absorbed. So it is absorbed there. So we can say that according to the system, total heat, according to the question itself, total heat absorbed is equal to RT2 ln 10, and we have got total heat absorbed from A to B and B to C. So that is 0 plus RT2 ln V3 by V2. So RT2 and RT2 will get cancelled. From there we can get the value of V3 by V2, and V3 by V2 value will be equal to 10. Now see, if you see the question, then they have asked the value of 2 log V3, but indirectly we can find the value of V3. As soon as the value of the V3 is got, then we can get the value of 2 log V3 as well. So V3 by V2 is equal to 10. So we have to get this value. So anyhow, if we can get the value of V2, then we can get the value of V3 as well. Now how to determine the value of V2 then? A to B, it is an adiabatic process. It is a reversible process and involving ideal gas. Since all these three conditions are satisfied, we can use this particular formula. T1 V1 gamma minus 1 is equal to T2 V2 gamma minus 1. And now what is the temperature from A to B? Initial temperature. Initial temperature, if you see, then at the point A it is given as 600. So we can use the value of 600 here. Initial volume, if you see, initial volume is given as 10 meter cube. So that 10 meter cube you can use. And gamma. What is gamma? Since it is a monoatomic gas, Cp value is given as 5 by 2R. That value is already provided. You can see here Cp is given 5 by 2R, and it's a molar Cp. And the Cv value is also, we can get the value. We know that Cp minus Cv is equal to R itself. So from there we can get the value of gamma. Gamma will be equal to Cp by Cv, that is equal to 5 by 3. So we are getting the value of 5 by 3 minus 1. T2 value is also given. You can see that at the point B the temperature is given 60 Kelvin. So 60 we can write, and volume V2 that we need to determine, gamma is 5 by 3 minus 1. So this value will get cancelled, so it will become 10, and from there we can get V2 by 10, and 5 by 3 minus 1, that will be equal to 2 by 3. So from there we can get the value of V2. V2 value will be equal to 10 to the power 3 by 2 into 10. So this is the value of V2. As soon as we are getting the value of V2, from this equation we can get the value of V3. V3 will be equal to 10 V2, and V2 value that we have got is 10 into 10 to the power 3 by 2. So that value will be equal to 10, 2 plus 3 by 2, that means 10 to the power 7 by 2. So this is the value of V3. Now if you take the logarithm both side, then this value will, to take the log both side, log V3, this value will become 7 by 2, and if you multiply that thing with the 2 further, then we'll get the value of 2 log V3, that is equal to 7. So 7 will be the correct answer. So the crucial formula that we have utilized here is this one. It will be applicable if it is adiabatic, reversible, and ideal gas is involved out there. And one more formula that we have utilized is here. And this formula will be applicable if it is reversible, isothermal, and ideal. So these two formulas, and apart from that, a little bit practice can solve this question. Thank you.